Hello everyone, welcome to another video of General Mathematics of Class 10, and today we are going to start chapter 10. But hello everyone, welcome to another video of General Mathematics of Class 10, and today we are going to start chapter 3, that is pair of linear equations in two variables. So what are we going to see in today's videos are how to express or how to represent pair of linear equations in two variables in a graph, and how to represent them algebraically. Then to understand that how many solutions a pair of linear equation can have, and in addition to that we will see how to solve those pairs of linear equations into variables. So these are our contents for the video. So without wasting any more time, let's get started. So the first thing that we are going to see today is, let us take one example of pair of linear equation in two variables. Okay, so two variables, so let us pick x and y, the most common variables that we have. So let me take a very simple equation. For example, x plus y equals 7 and x minus y is equal to 1. Okay, suppose these are the two equations that we have taken. Now these are a pair of equations. Okay, these are simultaneous equations, means the values of x and y must satisfy both the equations. One pair of solution means one value of x and one value of y must satisfy both these equations. All right, so what we have here are two equations, x plus y equal to 7 and x minus y equal to 1. Now let us see how to express this graphically. So what we will do first is we will make two tables. Let us take this as equation 1 and this one as equation 2. So this is going to be for equation 1, and another table we are going to make for equation 2. So here I have taken two boxes. You can take 3, 4, as many as you want, but minimum you need two boxes. So what we will do now, we will randomly put values of x and y that satisfy the given equation. For example, if x is equal to 3, then y is going to be 4, because 3 plus 4 is 7, right? So it satisfies equation 1. 3 plus 4 equals 7, values of x and y. Now let us take x as 1. If I take x as 1, then what is going to be the value of y? Y is going to be 6. So these two values, 3 and 4, and here 1 and 6, these two values satisfy our equation, which is x plus y equals to 7. It will satisfy this equation. Now let us move on to our next equation number 2. Now x minus y is equal to 1. We can take something like 4, 3, because 4 minus 3 is 1. Or we can take suppose 5 and 6. Not 6, 5 and 4, because 5 minus 4 is also equal to 1. So now these two values or these two pairs of solutions will be the solution for our second equation, right? So now we have two values or two pairs of values for equation 1 and equation 2. Now what we will do, we want to express them in a graph, right? So what we are going to do is we are going to draw a graph. Let's take out our scale, and we will be drawing our graph here. Okay. Hard to rotate this. Our y-axis, and now we will take our x-axis. So this is our x, this is our y, and obviously as usual we are going to plot some points. So I am randomly putting some points here, marks. Make sure you do this with proper scale, proper measurement. Okay, so these are 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. So now what we will do, for equation 1 we have two pairs, right? Here we have 3 4 and we have 1 6. So this 3 4 will can be taken as an ordered pair, which can be represented in the Cartesian plane, and 1 6 is going to be another pair that can be represented in the Cartesian plane. So first let us plot 3 4 for equation 1. So 3 and comma 4 is going to be somewhere here. This is our 3 comma 4, and then 1 comma 6 is going to be somewhere here, right? So this is 1 6 and this is 3 4. So what we will do, we'll connect these points, these 2 points, to get the line for the first equation, the graph of the first equation. So if we connect these 2 points, we get this line. Okay, this is our graph for equation number 1. Similarly, we will plot the values here as well. Here we have 4 comma 3 and we have 5 comma 4. So let us plot these 2 lines. 4 comma 3 is going to be somewhere here, and 5 comma 4 is going to be somewhere here. So if we draw another line, okay, so this is our 4 comma 3 and this is our 5 comma 4. Okay, so now this, the first line that we drew was for the equation x plus y equals to 7, and the second one is for x minus y equal to 1. Okay, so that's how we represent it graphically. So a pair of linear equation in 2 variables. First, we make a table, or we make 2 tables, one for equation 1, one for equation 2. In the 2 tables, we will plot the values of x and y in such a way that they satisfy the given equations. Here we have taken 3 and 4 for the first equation. So 3 plus 4 is equal to 7, and hence this is satisfying equation number 1. In the same way, we have taken 1 and 6, and 1 plus 6 is also equal to 7, and hence it also satisfies equation 1. If you want, you can take more points, 3, 4, 5 points, but a minimum of 2 points must be taken, because without 2 points you cannot draw a straight line. With a single point you cannot draw a straight line, because you will not know in which direction you have to draw. Suppose I take a point here, now I can draw infinite number of straight lines to this. But if I have 2 fixed points, then only one straight line can be drawn through these points. Okay. Next is the same we do for equation 2, so that the values that we write for x and y will satisfy equation 2. Based upon the values that we get, we will form their ordered pairs like we have done in this case, and we will plot those values in the Cartesian plane. Once we plot those values, we will get 2 lines for 2 equations, and that is how we express them graphically. Now this expression of the graph here in this case, we will find one point where they have intersected. The point where the 2 lines intersect, in this case it is this point here at 4 comma 3. This 4 comma 3 is the solution of the equation. That means both the solutions will be satisfied when x is equal to 4 and y is equal to 3. These are the roots of the equation, or you can say the solutions of the equation. Okay, that means, see, if I put x equal to 4 and y equal to 3, then 4 plus 3 is equal to 7. X equal to 4 and y equal to 3, 4 minus 3 is also equal to 1. So these 2 values, or these pair of values, actually satisfy both the equations. So this is the solution of this pair of linear equations. So that's how we express it graphically, and we also solve it graphically. Simple enough. Let's move on to our next topic, is how to understand whether is a given pair of equations how many roots will the given pair of equations have. Okay, so let me erase all of this and let us take the same equation to make it very simple. Okay, we have x plus y equal to 7 and x minus y equal to 1. Now in this, first we need to know what is the standard form of a linear pair of equation in 2 variables. So standard form, suppose one equation in 2 variables, we have ax plus by plus c equal to 0. This is the standard form. Now since we have 2 pairs of equations, we will write a1x b1y c1 equal to 0 and a2x plus b2y plus c2 equal to 0. So these are the standard forms. Now we will compare this standard form with our given equation. So as you can see, c1 and c2 are both on the left hand side. So here this is our a1x, b1y, c1, a2x, b2y and c2. So what we will do, we will compare, we will write it in such a way that they align with these 2 equations. Okay, so this will be x plus y, and we have to bring 7 to the left hand side. So it was plus, it will become minus equal to 0. In the same way, x minus y minus 1 is also equal to 0. So now these two pairs of equations, these pair of equations are in alignment with these two. Now what are the conditions? We have three different conditions, and based upon those conditions we can understand whether this given pair of linear equations in two variables will have how many solutions. Okay, so what are the conditions? Let us look into the conditions first. So if the ratio of a1 by a2 is not equal to the ratio of b1 by b2, then it will have unique solution. Unique solution means only one pair of solution, just like we have seen in the previous case. 4 comma 3, 4 and 3 were the solutions for x and y. There were no other values that would have there would be the solution for the given pair of equations. This is one case. Suppose a1 by a2 is equal to b1 by b2 and is also equal to c1 by c2. In this case it will have infinite solutions. Okay, we'll get into the details in a little bit, which will make it even more clear for you. The last case is if a1 by a2 is equal to b1 by b2 but is not equal to c1 by c2. In this case what happens? They have no solutions, means you can't solve this given pair of equations. Okay, so in one case, in the first case, we have unique solution. Unique solution means only one single pair of solution. X equal to 4, y equal to 3, done. That is the only pair of solution we have, and that is our unique solution. In the second case, what we have seen, if all the ratios are equal, then they have infinite number of solutions. Done. Many solutions you will get. In the third one is a1 by a2 is equal to b1 by b2 but not equal to c1 by c2. In this case, the equations will have no solution, means you can't solve the equation. Okay, now let us see what will happen if we draw them in graphs. Let us take this pair of equations as we have said and check what happens. So here we have, if we look into equation 1 and equation 2 and compare it with our standard forms, what will be the value of a1? See, this is our pair of equations. These are our pair of equations. So there is nothing, no constant is present in front of x. That means obviously it is 1. 1x plus 1y minus 7. So a1 is 1. What is b1? b1 is also 1. What is c1? c1 is minus 7. Similarly, a2 means this value, here it is 1. b2 is minus 1 and c2 is minus 1. Now let us find the ratios. So a1 by a2 is going to be 1 by 1, which is 1. b1 by b2 is 1 by minus 1, which is minus 1. So these two values are now not equal. So we have a1 by a2 is not equal to b1 by b2. That means they have unique solutions. So you remember, as we have done in the previous slide, what we saw that when we solve this equation, we got the answer 4 comma 3 and we got only one answer. That means they have unique solutions. So it has been proven. We have solved it first and now it also matches with the condition. That means we were correct, and here also the condition is matching. So this is an example of an equation which have unique solution, one pair of solution. Now if you have a1 by a2, b1 by b2, c1 by c2, all are matching, infinite solutions, and so on. Equation number 3. Now how do we represent them? So suppose we draw a graph. Let us take 3 graphs and see what will happen in each case. For unique solution, we have seen that if there are 2 graphs, they will intersect at a particular point, and that will be the solution. In case of infinite solutions, the lines are coinciding lines. Coinciding lines means if this is a line, the second line will also be on top of that line, means it will overlap the other line, means on top. So it is basically the same line. So now why it is infinite number of solutions? See, the solution is the point where the two lines intersect. Okay, here both the lines are coinciding, means they are intersecting at all the points. They're overlapping each other at all the points. So if they overlap each other at all the points, that means there will be infinite number of points at which they overlap or they intersect. That means they will have infinite number of solutions. In case of, now what will happen in case of no solution? So if we draw the graphs, we will see that the lines that we obtain by drawing, the lines that we obtain by drawing the equations which have no solution actually contain parallel lines. So these are intersecting lines. These are coinciding lines. And these are parallel lines. And parallel lines will never intersect each other. And as they will never intersect each other, there will be no solution. You cannot find any solution. Okay, so that is how we represent them graphically. I hope it makes sense now, all of this that we have seen. One more thing that should be added here is consistent equations and inconsistent equations. So consistent equations means if you can solve and get either one or many solutions for a given pair of equation, those sort of equations are called consistent equations. And if you cannot get any solution, means no solution, that means it will be an inconsistent pair of equation. So see, look into our conditions. Here we have unique solution and here we have infinite solution. Means you can get solution, either it will be one answer or many answers. So these are consistent. And this one here, no solution, is inconsistent. Okay, these pairs of equations are called inconsistent pair of linear equations in two variables. So if we look into the graph, since here we are getting one solution, so it is obviously consistent. Here we are getting many solutions, infinite number of solutions, so it is also consistent. And in this case, parallel lines, obviously they are not intersecting, so it is inconsistent. Okay, so that is how we understand consistency of equations and inconsistency of equations, how many values or how many solutions we are going to get for a pair of equations, linear equations in two variables, and whether we are going to get a solution or we are not going to get a solution. How to draw the graphs, we have seen it all in this pack of the video. So this was our first part of the video. Now let us move in to the next part of the video and see how to solve them. But in order to do so, you have to look into our next video that we will be uploading, and obviously I'll upload them both together today itself. So the next video is also uploaded. You can go ahead and check the video. I'll attach the link down in the description, and also you'll find it somewhere here on the screen. Okay, so go ahead, watch that video, and in that video you will see how to solve linear equations in two variables in different methods. We have three different methods here: substitution, elimination, and cross multiplication. And in the next video you are going to see it all, how to solve it in three different ways. The reason I made the next video is because I don't want to make this video too long and make it boring for you. So watch this video, take some rest, have maybe a slice of bread. You can have a slice of bread, that's up to you. Enjoy yourself, relax, and then move ahead to the next one. You try the exercises, because in the NCERT book of General Mathematics of class 10, this video that I have made covers exercise 3.1 and exercise 3.2. So two exercises have been covered in one video. In the next video, we are going to cover exercise 3.3, 3.4 and 3.5, how to solve, not problem sums, only the direct equations that have been given. Okay, so go ahead, watch that video. Thank you for watching, and see you in the next one in a short while. Goodbye.